Okay, so in order to start page 2, we really kind of need to go back to one or two sentences on page 1. It says in a marine food chain, plankton, phytoplankton, is eaten by a herbivore, which in turn is eaten by a carnivore, which is then eaten by another carnivore, so on and so forth. Eventually, decomposers recycle the remains back to primary production at the base of the food chain in the form of inorganic nutrients. Well, such simple food chains rarely exist in the ocean, and marine heterotrophs are more likely to feed on a variety of prey organisms. Okay? Most marine ecosystems consist of several levels of consumers, including fish, marine mammals, and seabirds. The complex feeding relationships within marine ecosystems is more realistically described as a food web, and each level of production and consumption is called a trophic level. Marine animals rarely feed at only one trophic level. Okay? And remember that trophic levels, remember when you look at an energy pyramid, each step in the pyramid is a trophic level. Okay? At the bottom of any energy pyramid are your producers. And remember that producers are also known as autotrophs. Just to prove that you're listening, put producers equals autotrophs up here. Okay? And then I also want you to write out that producers form the bottom of your energy pyramid and are the lowest trophic level. All right, so I have added this set of highlighting that the complex feeding relationships within marine ecosystems is more realistically described as a food web, and each level of production and consumption is called a trophic level. Okay, I also added this note out to the side. Autotrophs are always the bottom or lowest trophic level. They form the base of the energy pyramid. Okay, and remember there was a place up there I asked you to put that autotrophs equal producers. Okay. Within food webs, energy is transferred in only one direction, from lower trophic levels to higher trophic levels. For example, from producers to consumers. As an organism occupying one trophic level feeds on its prey, only a small portion of the energy stored in the tissues of the prey is passed on to the next higher trophic level. We can visualize the energy distribution within a food web as a pyramid with producers forming a broad base. Each successively higher trophic level contains considerably less energy and biomass than the one below it. Ecological efficiency is the percentage of energy that passes from one trophic level to the next. An ecological efficiency of 10% is typical of marine ecosystems. Ecological efficiency is low because not all parts of a plant or animal are eaten. Not all of what is eaten is digestible, and not all energy is converted into biomass. Okay, so before I show you what I want to highlight, let me give you an example of what they're talking about. Y'all have seen energy pyramids. You know that the most energy and biomass is available at the bottom of the pyramid where your producers are. And it gets, the levels get smaller and smaller as you go up. If you think about this, this is kind of just an oversimplified example, but let's say that you go to the grocery store and you buy one of those rotisserie chickens, you know, one that's already been like cooked and everything for you. And it says it's a 1 pound chicken, which is probably not that heavy. When you buy it, that's 1 pound. But when the chicken was processed, it began as a whole chicken. So there's some parts that didn't wind up in your rotisserie chicken. Feathers, maybe skin, maybe, I don't think that they debone it. But anyway, what I'm saying is already you don't have all of the biomass that was part of that chicken. And then if you go back and you think about, all right, let's say that the chicken that went to the processing plant, let's say that that chicken was a 2 pound chicken, okay? Think about how many pounds of chicken feed that chicken was going to have to eat over the course of its life Okay? And it's a whole lot more than just 2 pounds. So that chicken consumed a whole lot of biomass from a lower trophic level, basically from the producer's trophic level, okay, just to come up with that 2 pounds that it was when it was slaughtered. And then when you buy your little rotisserie chicken, you don't even have the whole 2 pounds. You have less than that. So energy is lost as you go up each trophic level, okay? Think about yourself. You might weigh, 150 pounds. But over the course of your lifetime, how many pounds of food do you think you've consumed? Well, you've consumed a whole lot more than 150 pounds of food. You've consumed probably many, many times that. Okay? And so what I'm trying to get you to understand is that each organism dips down into a lower trophic level where there's more energy. And as you go up, there's less and less energy available. Okay? So let's just say that the chicken, it took 20 pounds of chicken feed to make a 2-pound chicken. Well, already you see that only about 10% of the lower trophic level wound up as part of the biomass in the chicken. Okay? And it just gets worse, it gets less and less as you go up. Okay? Just to prove that you were listening, out here to the side, I want you to do your best to draw me a chicken. Okay? Or a little chick, something like that. All right. And then we're going to move on and start. Oh, I've got to show you the highlighting first. Hang on. Okay, so make sure that you highlight within food webs, energy is transferred in only one direction, from lower trophic levels to higher trophic levels. For instance, from producers to consumers. Only a small portion of energy stored in the tissues of prey is passed on to the next higher level, trophic level. Think about the chicken. It may have taken 20 pounds of chicken feed to just produce a 2-pound chicken. That's probably oversimplified, but you get my point. Okay, we can visualize the energy distribution within a food web as a pyramid with producers forming a broad base. Each successively higher trophic level contains considerably less energy and biomass than the one below it. Okay? All right, so now we are going to start these questions. Number 1, in a marine food web, the lowest trophic level is occupied by what? Autotrophs, herbivores, or carnivores? What does it say over here? It says autotrophs are always the bottom or lowest trophic level. So, number 1, the lowest trophic level is occupied by autotrophs. So highlight or circle autotrophs. Number 2, the next higher or second trophic level is going to be the organisms that feed directly on autotrophs. The things that feed on autotrophs, feed on producers, are your herbivores. Okay? Herbivores eat plants, or if it's a marine ecosystem, herbivores will eat phytoplankton. So number 2 should be herbivores. And energy is always transferred from what to what? Well, it's always got to go up from lower trophic level to higher trophic level. So we start at the lowest, which is autotrophs, and it's transferred to heterotrophs. So we go autotrophs to heterotrophs. That's the first choice. Okay. In other words, just to prove that you're listening, you can also put down here from producers to consumers, because autotrophs are producers and heterotrophs are consumers. Okay. All right, and then an ecological efficiency of 10% in a marine ecosystem means that how much of the energy consumed at one trophic level is not passed on to the next higher trophic level. Well, if 10% is the efficiency, that's basically telling you the percent that is passed on. Okay? Think about the chicken. 20 pounds of chicken feed to make a 2-pound chicken. Only 10% of the 20 pounds made it to the next level, 2. Okay, so that's a 10% efficiency. So 10% is the part that is passed on. So what is not passed on is the other 90%. Okay. The lower the trophic level at which an organism feeds, what? The less or greater the amount of biomass. Well, think of your energy pyramid. Your lower trophic levels are going to be wider and broader, which is because they have more energy. So your lower trophic levels are going to have greater biomass available. Okay? So that's number 5. All right, and then number 6 says, in order to have a sufficient food supply, blue whales, the largest living organisms on Earth, must feed at what? Lower or higher trophic levels? Well, you're talking about a really big animal. So a really big animal is going to be needing quite a lot of food. And is he going to go search for that at lower or higher trophic levels? Well, first of all, it says here that blue whales primarily eat krill, and krill is fairly low in the energy pyramid, okay, because it feeds on like plankton, okay? And if you're talking about needing more energy and more biomass, then you need to go down into the lower levels of your energy pyramid, okay? So number 6, they're going to need to feed at lower trophic levels, okay? So make sure you circle lower for number 6. And then it says, consider the following food chain. Phytoplankton are eaten by copepods, which are minute crustaceans, not minute, minute crustaceans, small crustaceans. The copepods are then consumed by herring, which are ingested by mackerel, which in turn make a meal for a swordfish, and finally a person in a restaurant orders the swordfish for dinner and eats it. Okay, so we're going to use that to consider some things for the next page. Okay, so keep that food chain in mind and pick up with the next screencast.